Unearthing ancient treasures. How a fossil from the ocean floor ended up on a mountain. Nature hides its greatest stories beneath layers of rock, mud, and time. One of the most astonishing tales is how a fossilized marine creature, once buried deep beneath an ancient sea, can end up exposed high on a mountain peak, like a forgotten message from Earth's ancient past. Let's take a journey through millions of years of geological movement, erosion, and tectonic drama to see how an ancient fossil can become a modern-day treasure of scientific knowledge. From ocean floor to fossil millions of years ago, in a warm shallow sea, a marine creature, maybe an ammonite, trilobite, or even an early fish, lived, died, and settled onto the seabed. Over time, it was buried by sediment, compacted by pressure, and turned into stone, a fossil, sealed within layers of oceanic crust. This fossil, now a silent time capsule, was just the beginning of an epic journey. The power of plate tectonics. The Earth's crust is not static. It's broken into massive slabs called tectonic plates that float atop the molten mantle below. These plates collide, shift, and slide, reshaping continents and ocean floors. As tectonic plates collide, they can force sections of the ocean floor upward, forming mountain ranges. The Himalayas, for example, were formed by the collision of the Indian and Eurasian plates, and marine fossils have been found at their peaks, proving that these towering rocks were once beneath ancient seas. A fossil's ascent. Our buried fossil may have been carried upward over millions of years, lifted inch by inch, squeezed and folded into rising mountain chains. Eventually, what was once an ancient seabed became the summit of a mountain, a world of ice, wind, and sun. But the fossil didn't emerge immediately. For eons, it remained buried beneath layers of rock and soil. Wind, rain, and revelation enter the slow, patient work of erosion. Over thousands and thousands of years, rainwater, frost, wind, and heat began to wear down the mountain's surface. The elements chipped away at cliffs, carved valleys, and peeled back the layers of time. Eventually, the fossil's rock layer was exposed, maybe in a cliff face, or washed into a valley below by a landslide or flood. And there it was, a perfectly preserved fossil, a window into a lost world, exposed to the sky for the first time in 200 million years. The other way around, into the depths, but Earth's forces don't just move up, they also move down. That same mountain, millions of years from now, might be pulled back into the Earth through subduction zones, where tectonic plates dive under one another. The fossilized rock could be drawn into the mantle, melted, and possibly ejected again in a volcanic eruption, its atoms reborn as part of new rock, or even lava. More than just a rock to the untrained eye, a fossil on a mountaintop might look like a strange rock. But to scientists, it's a treasure trove of information, proof of past climates, extinct life, and shifting continents. It tells us that what is now land once was sea, that what is high was once low, that the Earth is alive and always changing. Conclusion. Ancient Earth, modern discoveries. The next time you hike a mountain, pause and look at the rocks around you. Beneath your feet might be the remains of an ancient ocean, or even a fossil waiting to be discovered, a relic of a world long gone, brought to light by the incredible forces of geology and time. And when you hold that fossil, remember, you're holding a piece of Earth's memory.